Hey there, today you're going to learn how to make a video game. Even if you've never touched video game development in the past, never written a line of code, maybe even never seen a line of code before, I'm going to take you through all of the steps that you need to know how to make a game, understand how that game works, and then take those skills to start building your own games. If you've ever wanted to get into game development and thought, this is just too hard, I promise by the end of this, you'll think, wow, that was easy. I'm amazed and I'm very happy that I went through the process to learn video game development. It's going to be a lot of fun. You're going to learn a lot really, really fast, and it's not going to be difficult. I've taught this to 5th graders. You can definitely go through this process, build your own game, publish it, and release it, and share it with your friends and family. Before we get started, let me show you the game that we're going to build. It's a simple Flappy Bird style game where you jump and try to get through obstacles, but you can actually make it to the end. We use some blocks to keep the theming simple and make it so you can extend it and change it out however you want in the end, and give the players some actual skill-based goals. They can jump forward a little bit, they can avoid that wall on the back and try to make it to the end, all while counting up a high score and trying to beat each other or just beat their previous scores. I found that a lot of people would just keep playing it, and you can go try it out right now in the link below. Now let's talk briefly about tutorial organization. Everything in this video is broken into chapters so you can easily get back to or jump ahead to parts that you need. If you already have Unity installed, you might want to skip past that part. If you, however, need to mark a position in the video where you need to resume, feel free to just drop a timestamp down below. I've seen that a lot of people do that, and it seems to work really well. And finally, before we get started, make sure you hit like and subscribe. To build a game, we'll want to use a game engine, and the game engine we're going to use today is Unity. You can download Unity on their webpage at the unity3d.com/getunity/download page. I'm going to choose the Download Unity Hub option because that's what I recommend everybody use. The Unity Hub allows you to manage your Unity projects and different Unity install versions. As you upgrade your projects and upgrade to newer versions of Unity along the way, it comes in really handy. Once it's done downloading, you can just click Open File to run the installer, allow it to launch when it pops up with the little prompt, and then choose Agree to go through the licensing. Choose a folder. I usually just leave it at the default and hit Install. Once it's done, I'll leave the Run Unity Hub option checked and hit Finish to launch the hub. When the hub starts up, it'll probably ask for firewall access, so make sure that you allow it. And then you'll probably be presented with this not very helpful screen that says that you have no license and you need to manage it. The next step is to just hit the Manage License button or click right up here and choose Sign In. You need to log into a Unity account. If you don't already have one, you can just choose the Create One option. Otherwise, you can sign in with your existing account. If you have a Google account, Facebook, or Apple one, you can also sign in with those and then link them up to a Unity account. You will need to have a Unity account though, or a Unity ID, and it'll have you create one in that process. And you need that to keep track of things like your asset store purchases and files that you might commit into source control so that they're all linked up and it's easy for you to share them across computers. Now let's go through the account creation process together real quick. We'll hit the Create One option, enter a new email address. Choose a password that matches all the requirements. New username, and put in our actual name. Check all of the boxes and hit the Create Unity ID option. Within a few seconds, you should get a confirmation email. Just go to that email, click the link to confirm your email address, verify that you're not a robot. After that, your hub might look a little bit weird. Just hit the back button and you'll be ready to go. Next, we need to install a Unity version. With the hub set up, we can install multiple Unity versions by just hitting the Add button. I'm going to hit Add, and we're going to choose the latest official release. We're not going to choose the recommended. The recommended is going to be Unity 2020.3 right now, and it's going to be whatever the most recent long-term support version is. We're going to use a newer version. We'll use Unity 2021.1.12 F1, or whatever the latest official one is there. Don't go down and choose a pre-release unless you have a very specific reason for it. And if you're watching this video video, you don't have one. Just go for the latest official release, hit next, and then hit next again. Leave the default options there and hit I have read the terms and hit done. We don't need to add in anything else extra to get started with Unity. We can always add in the extra add-ons and the extra support for building to mobile devices, to web platforms, and everything else right through the hub just by clicking an option in here. It's very easy to change that now, so there's no need to just bloat your install by adding a bunch of things that you're not using yet. Just leave the defaults with the default code editor set up, and you'll be good to go. Now, if you already have your own code editor set up, I'd still probably recommend going with the default one for now until you get familiar with it, because there are going to be some changes and there's a little bit of integration going on with Visual Studio and Visual Studio Code, depending on your platform. So don't just go swapping out the editor right away until you've gotten familiar with it. The install can take quite a while though, so if you get bored while you're waiting around, go check out my YouTube channel, subscribe, and see some of the other videos. Maybe find out a little bit more about game development and game programming versus game design, or some of the other game development opportunities that are out there. Or another option is to just watch the full video all the way through, maybe at 1.5 times speed while the installer is going, and then rewind it and go through the project once you're done with the install. That way you'll have a good idea of what's coming up, you'll have an idea of what you might be able to customize and where you can have some fun with it, and just be a bit more prepared to make the process easier as you go through it. Before you can create a Unity game, you'll need to set up your license. To do that, you can click the Manage License button down below, or if you can't find that, go to Settings and then go to License Management. Choose the Activate New License option, and then choose the license that applies to you. If you're not using Unity professionally yet, and you're in an organization that's just not making any money, Unity Personal probably applies. Otherwise, you might need to check out Plus or Pro. You can just choose the I'm not using Unity in a professional capacity if that actually applies to you though, and hit the Done button. That should activate your license. If you get an error with it or something kind of bugs out, just try closing and restarting the hub. Occasionally there are connection errors or something else goes weird. Now that our game engine's set up, it's time to create our project. Go back to the main hub page and go to the Projects tab. When you're in the Projects tab, you can hit the New button or choose the drop down if you have multiple Unity versions installed. We only have one though, so we'll hit the button, go to the 2D template, and then we'll give our game a name. I'm going to call this Crazy Blocks. And then choose a location where you want to save your projects into. My general recommendation is to create a folder off of your root drive where you save the projects, but if you're not very familiar with folder management or computer management, then leave it wherever you feel comfortable with. I'm personally, though, going to put mine into a folder named C:/projects, where I save off all of my game projects. Then I'll hit the Create button. This will create my game project, and it's going to take a few minutes. Depending on the speed of your system, this could be anywhere from 15 seconds to 3 or 4 minutes. There's a lot that goes on in the creation of the project, and well, it just takes a while. Unfortunately, it seems like it gets slower and slower over time, but hey, what are you going to do? While your project is creating, by the way, why don't you go ahead and hit the like button and subscribe if you're not already. So that way you'll get more info about game development, see more tips, and find out about other ways to make fun and interesting games, and just kind of learn more about the game development industry while you're on this journey of making games on your own. And it'll make me happy. Before we start creating, let's do a quick review of the game that we're going to build. It has a very simple concept. We have a player that can jump by clicking or tapping on the screen. They have to dodge these little pink blocks that are coming out to push them into a red area that wants to kill them and try to get the highest score possible. There's a bit of skill involved and players can get better at it over time, and it's also extremely easy for us to make. So let's get started recreating this now. We'll start by creating our player. To do that, we'll go to the Game Object menu, choose 2D Object, Sprites, and then Square. Our player is a green square, so we'll just make a square right here in the middle of our game. I'm going to name it Player. By default, it's going to be in a rename mode. That's why it's blue, and I'm going to name it Player with a capital P. If you don't get a chance to rename it or you hit Enter or something else, you can always hit F2, or you can click twice slowly to get into rename mode and then name it player. With that object selected, so it'll be nice and blue when it's selected, I'm going to find my inspector tab. Right now it's got the collaborate tab, which is for source control, which is a more advanced topic that we're not going to cover today. Instead, I want to go to the inspector window or the inspector tab. Now, if you can't find it, your things look a little bit different or it's not laid out exactly the same, you can always go to window, layouts, and then choose default. That'll reset our layout right back to the default, but it'll also collapse our scene. So all of our objects, like our player, might not be visible. You want to expand that out by clicking the little arrow so that you can see our player and go reselect him. All right, now I've got our player selected. It's in the inspector tab and I want to make him green. You may have already guessed how to do this, but if not, choose the color option right here. You'll get a beautiful little color picker. Choose the shade of green that you want to have and then hit the X button when you're done. That's it. We've got a green, I almost said blue, but a green player now. Next, I want to create a ground that our player can fall onto because the first part of our game is going to be the player falling onto the ground. So let's create a ground object by doing the same process. We'll go to Game Object, 2D Object, Sprites, and choose a square again. This one is going to be a different color. I'll choose maybe a purple color. And notice that it's kind of on top. Let's go with a darker purple. It's on top of my player right now, though. It's covering the player up. And I don't like that. I want to move this square around. So what I'm going to do is set the position. There are a bunch of different ways to set a position in Unity. The first option is to just go to the transform value and look at the position. It has an X, Y, and a Z. Since we're doing a 2D game, we're just going to look at the X and Y values and always keep the Z at 0. If you don't see these, make sure that you expand out the transform. It can be collapsed as well. I'm going to start by just setting the positions to 0 and 0 because mine were a little bit offset. If yours were at 0, 0, that's great. It just means that you didn't move the mouse before you created your object. Now, that's not where I want my object to be. I really want this to be a ground piece, so I want it to be down at the bottom. I'm going to move it down to the bottom by making the position Y value be lower. I can do that by just clicking on the Y, holding the mouse, and dragging down. You see that the value goes down and it moves down along the ground. I think I want to put this at about a -5, so I'm going to drag it to exactly -5, or just click in here and type in a -5. Now, I also want to make this thing wider. To make something wider, I don't need to adjust the position. I don't need to adjust the rotation. Instead, what I need to adjust is the scale. Scale is how big something is, either how wide it is, how tall it is, or if we're in 3D, how deep it is. Since we're in 2D again, we have a 1 for our Z, and we're never going to go any deeper. But we can go wider by just changing our X scale. I'm going to set the X scale here to a 20, so that it's this full size of our game view, or the full size of this white outline showing what our players can see. That looks pretty good. I'm going to now hit Control S to save my scene, or I could go to File and Save. That just saves my current progress so that if something goes wrong, my editor crashes, my computer shuts off, or something else, I have my stuff saved and I can get back to it later. Now let's hit play and try our game out. So we play, and notice a couple things happened. First, the scene view tab kind of went away. I can click on it and go back to it and see it. This game view tab instead popped up. The game view tab shows us what our players are going to see. Now there's something interesting here to note. While nothing fun is going on in our game, we can see the edges of our little purple ground area here. The reason for that is that we're in free aspect mode. And free aspect mode is a way for the game engine to scale to just about any resolution. If you've ever wondered how a game can just kind of magically work at any resolution, you go buy a game and you play it on different monitors and it still kind of works, it's because they do some automatic scaling. We're not going to support very much automatic scaling though. We're going to go with a 1920 by 1080 resolution, which is just a very standard one. We're going to stick with that and build our game around it. So to change it, we're going to use this little drop down here and choose the Full HD 1920 by 1080 option. Now you see that the borders are closed in and things are looking a little bit better. Now we'll go back to the scene view and start adding some physics to our game so that it's interactive and fun. First, we're going to go to the player and we're going to add a component to it. The player is a game object, and a game object is really a collection of components. We've got a transform component and a sprite renderer component already on there. Those were added automatically when we created our 2D sprite that was a cube. We're going to add a new component though, and we're going to choose a 2D physics option, or a 2D physics component. We'll go to the physics 2D section and we're going to choose the rigid body 2D option. Now, a rigid body is what controls physics for an object in Unity. A rigid body 2D handles 2D physics. So if we're building a 2D game, we want to use a rigid body 2D on any object that's going to move around and interact with physics. So here we've got our rigid body 2D. Let's hit play and see what that does to our game. We should expect to see our player suddenly just fall down and go right down through the ground. Now, the reason that our player falls through the ground is that there's nothing to collide with. There's no collision setup done yet. So we're going to create a collision setup now. To do that, we'll create a collider or add a collider component to our player. First, I'm going to collapse a couple of these other components. I'll collapse the sprite renderer and I'll collapse the rigid body 2D. If you ever have a hard time finding components, make sure that you look to see if they're already there and just collapsed. Sometimes it's easy to miss them and they're just already there and you can add duplicates or something else. Let's hit the add component option now and let's choose a 2D physics option that matches with our box or our 2D square. A box collider 2D seems like the perfect option, so that's what we'll add. If I zoom in here, you would be able to see that it has a nice little green outline, except for the fact that I chose green for my player color. Let's disable the sprite renderer by unchecking the box, and now you can kind of see that green outline. If I uncheck the box collider, you see that that green outline goes away, and if I check it again, it reappears. That outline is showing me where this object will collide. So when this box wants to hit something, it's going to use that to do the collision instead of the actual sprite image there. Now I'm going to recheck the sprite and recheck the box collider so that they're both selected. Zoom out with the mouse wheel and then hold the right mouse button to drag around so that I can go select my ground piece. And my ground piece right now is named square. I want to rename it to ground. To do that, I could go over here and hit the F2 button like I showed you earlier, or I can go to the inspector, click up here and just start typing the word ground. Now I have a ground object that just needs a physics component of its own. My ground isn't going to move, so I'm not going to add a rigid body 2D. Instead, what we'll do is go to our physics component and just add another box collider 2D. There you probably saw the green outline appear. Let's hit play now and see what happens. There we go, we've got a box that falls onto the ground. Things are starting to look up and it's time to start writing some code. If you've been worried about writing code, don't worry any longer because you're going to see just how easy it is. We're going to start by creating a new script to control our player. And controlling our player really just involves having our player jump. To do that, we're going to create a new script in our project view. Down at the bottom, you should see a project and a console view. Again, if you don't see those and your layout's a little bit weird, you can go to Window, Layouts, and choose Default. Down here in the project view, you should be able to right-click, choose Create, and then choose C# Script. If I don't hit anything, I'm going to get into an automatic rename mode. But it's possible that maybe I hit Enter and I accidentally leave the name of this thing as New Behavior Script. If I do that, my general recommendation is just hit Delete. Yes, I want to delete it. It's okay. And then I'll recreate the script. The reason for that is that when it generates a class file inside of that file, or a class inside of that file that matches the file name. And if the names don't match, you run into some weird errors. So let's try again. We'll go right click, create a new C# script, and this time I'm going to name it player with a capital P and a lowercase for everything else. Now that's not a requirement, but it is a standard set by Microsoft, something that I highly recommend that you use. Capitalize the first letter of every word, and that's all. No spaces, no underscores, no other weird characters in there. Just single word, name, player with a capital P. Now I have a script, and you'll see that my inspector has updated to show me what that code looks like. That is not where we're going to look at code though. It's pretty much never a place that you want to look at code because that inspector is kind of tiny, useless, not editable, and not formatted well. Instead, we want to double click on the player file to open it in our default editor, which will be either Visual Studio or Visual Studio Code, depending on your operating system. this should present us with a player class file that looks exactly like this. Now, if you have an issue with it, it doesn't open or something else goes wrong, you can always close Visual Studio or Visual Studio Code and try again. Another option that you would want to look at though is go into Edit and then go to Preferences. And then in the Preferences section, there's a choice for external tools. In here, you can choose your external code editor. Sometimes I use Writer, sometimes I use Visual Studio, but you can also hit this Regenerate Project Files. That should fix any issues if you start to have problems, you're just not able to open up your code editor. Let's go back into the code editor now and start writing some code for our player. Now, if you've never seen code before, this player class that are automatically generated might seem a bit confusing and daunting, but don't worry, we're going to go over it really quickly and explain what the different pieces are. Right at the top, we have 3 using statements. Those tell the game that we want to bring in some external libraries. Even the Unity engine is technically an external library. The light gray ones are just ones that are really commonly used, but we haven't used them yet in our file. It puts them in because it just assumes that we're probably going to use something from those libraries. Those are collections or sets of data. You'll see how we use those later on though. For now, we just want to look at what's inside of our actual class. Here you'll see that we have a public class named player, and it has this colon and a mono behavior behind it. All of that might seem confusing. What it really means is we have a component that's a player component, and it uses this mono behavior component to be a Unity component that can go onto a game object. So for any class that we want to have that can go onto a game object, we need to have essentially a line like this that matches the name of the file with the class name. We'll do this for a player, for a moving thing, for something that can kill players, or maybe an enemy or a weapon. You could have a class for all kinds of different things. They all are things that you want to be components of your game. Inside of this class, you can tell it's inside because it has these braces, and I can collapse and expand it here. So inside of this class, we have 2 things that are called methods or functions. These are code that run and do different things at different times. It has a little comment here that the start method is called before the first frame update. Now that might seem a little bit weird. Really what it means is the start method is called at the beginning of the game, or at least in our case, at the beginning of the life of our player, which is the beginning of the game. The update method down here is called once per frame. Now a frame is every time the screen is rendered. So if we're rendering our game at 60 frames per second, update is called 60 times a second. If you have a really fast video card and you're running at 1,000 frames a second, update is being called 1,000 times per second. Update is where we're going to write our code. Update is where we're going to handle jumping with our player, reading input, and applying physics forces. So what we're going to do first is just delete out the start method completely to clean it up and make a little bit of space for ourselves. To do that, I'm going to take the end of line 12 here, select it, click and drag all the way up to the beginning of line 7, and hit delete. I want to make sure that I don't leave any extra braces or delete any extra braces and have it match exactly like this. Now inside of our update method here on line 11, again, I know it's inside because it's between these 2 braces. These define the inside of our update method. I can collapse and expand it to see what's inside it. What's inside it will disappear. Inside of the update method, we want to add in what we call an if statement. Now an if statement is going to do something conditionally, and it's going to do something conditionally based on whether or not the player has pressed our jump button. Let's start writing it, and then we'll explain how it works. We'll write the words if, or the word if, lowercase if, and then an open parentheses, which is shift and the 9 key by default, or at least on my keyboard and most keyboards. It's a shift and the 9 key. It's going to automatically add a closing parentheses and then allow us to start typing in here, at least if you're using any normal code editor. If you decided to go with Notepad or something, maybe you're not getting the autocomplete, but everybody else should be getting that. You say if, and then inside of here, we want to use the word input with a capital I, I-N-P-U-T, dot, and now there are a bunch of options that are going to pop up on this little autocomplete or IntelliSense menu. The one that I want to choose, and I can type the word in, or I can just go down here and select it, is the get button down. I highly recommend that you kind of scroll through and look at these though every now and then, get an idea of what types of things are there, and start to use that as a way to explore and experiment and learn a little bit more. We're going to use get button down though, so I'm just going to select it and hit enter, and then we'll open up another parenthesis. So another shift 9 here, and then quotation marks, which is shift and the key next to enter. So it's just a double quotation marks. What we're doing here is we're going to check to see if the player has pressed the button, some button down that's named whatever is inside of our quotation marks. The name of this button is Fire1 with a capital F, F-I-R-E-1. Now you might think I don't want mine to be Fire1. Don't change the name. We're sticking with Fire1. It's really important because that's the default. You can change it later. I'll show you how, but for now use Fire1. Now it's got an error here, this little red thing saying that there's an invalid expression term with a closing brace and it expected a semicolon. If you put a semicolon here, it's going to seem like things are right, but it's actually totally wrong. That's not what we want at all. What we want to do is, if this statement is true, if they have pressed this button, we want to run some more code. We're going to run more code by adding in a line of code right after it with some braces. So I hit enter and we'll add in a shift and the little squiggly brace. This is right next to P. So just to the left of P adds in my little brace. It's the same brace that you'll see here on line 10. And I'll hit enter. And what we're going to do is add in the code to jump whenever our player has pressed Fire1. To jump, we need to first get our rigid body component and tell that rigid body component to start moving upward. Let's take a real quick look at our game object real quick and see what that rigid body component looks like. So if we go to our player and we're right here, we've got this rigid body 2D component. When we access this from our other component that we've just created, our player script, we'll be able to tell it to jump. Now first, we need to add our player script to this game object, because without having it on this game object, it's not going to have a way to get or reference this rigid body. So I need to add my player component to my player game object, and there are a couple ways I could do this. First, let me collapse the rigid body in the box collider. I could first just drag the player over here and snap it on there. Now I have a player component. I can remove that though. Maybe go to the add component menu and just search for the word player and have it pop up there as well. Now, I want to note that if it doesn't show up, you can't add it or you get an error message, make sure that you go back to the player script and can do a build. Do Control-Shift-B and you should see if there are any errors. Perhaps I'm missing a brace there. I try to do a build. I won't be able to add my player component until I've fixed it and successfully done a build with the player script working. So I'm going to go back here. We'll fix it by adding the brace back in. Let's take one more look at the class and the full code real quick. And then let's add in the code to access that rigid body and tell it to jump. So to get the rigid body component, we're going to use the getComponent method, which is actually part of the mono behavior class that we're using. The reason that we have to use this mono behavior, if you're familiar with C# or inheritance at all, is to access quite a few of these methods and to become a component onto game objects. So we'll get the component, the rigid body component, by saying getComponent. And there are a bunch of getComponent options here. You'll see that it auto-completes to getComponent, a getComponent with a less than and greater than, getComponent in children, less than and greater than in children, parent, getComponents with a plural, and then a whole bunch of other ones. Try getComponents. What we want to do is getComponent, and we want to use this one that has the less than, greater than, which is actually a generic type symbol. So it's going to get a component of a type. So I can't auto-complete and have it appear there. I just need to type the less than symbol, which is shifting the key next to M, and give it the type rigid body 2D. I need to make sure I get the 2D one. Go over to the right one character outside of that type declaration, which is what those arrows are, and then give it an open close parentheses. That's going to make it actually call the getComponent method with the rigid body 2D type. The open close parentheses are kind of like saying, hey, go execute this. Now, assuming we have our rigid body there, which we do, this will allow us to do things like modify the velocity. So let's do that now. Let's set the velocity by putting a dot to access a property or a method. Here we want to access one of the properties, which is the velocity property, and we're going to set it or assign it using the equals operator. So to say the velocity is equal to some velocity. Now you might think, what velocity? What does that mean? What's our velocity? How would we figure that out? How would we even know? Well, what we can do is create a variable. We can make this a very easy thing to experiment with and play with and adjust as a game developer or a game designer. We're going to call this jump velocity. Now I'm going to type in the name, JUMP VELOCITY, with a lowercase j and a capital V. Here we're using something called camel case. When we create classes, we use that uppercase P, the Pascal case. When we create variables like this, we generally use this camel case, where we start lowercase and then use uppercase letters for everything after the first word. So I'll hit Alt Enter, and now we want to generate a field for it. A field is a thing that lasts on our class that's accessible by all of our methods. It's a way to store data or have data on our class or on our game object that we can use to save off whatever it is we want to save. This could be health, it could be our speed, here it's our jump velocity, it could be our ammo or whatever other thing we want to have. I'm going to hit enter and just allow it to generate a field. Now that automatically created a line 7 here that says private vector2 jump velocity. You could just go type this in yourself too. That automatic creation is just a little shortcut. You can just go retype that in. It's going to be exactly the same as long as the naming matches. We do, however, need to make one little change to it. We don't necessarily need this private keyword. It's kind of redundant and just automatically generated. So I'm going to double click on it, and we're going to make this accessible inside of the inspector. To do that, we're going to add a square brace, which is the key right next to P, and then add in the word serialize field. You can see that if I just type SER, it kind of auto-completes. I can hit enter and then add in a closing square brace here. Now, last thing I want to do is hit Control S and save. Make sure that everything is working with Control Shift B. That'll do a build. And right at the bottom, it should say build succeeded. If there are any errors, it should give me an error and let me know exactly where to go fix it. Let's see what that would look like. Say I was missing that line. I did Control Shift B and I got an error, and I double clicked on this and say, hey, there's something missing. It's missing an extra brace here. And I could just add in a brace and it would probably fix the problem. Now, that's not always the solution. Sometimes debugging is a little bit more complicated than that. But in our case, that scenario was kind of simple and our class is really small. Let's save one more time. Let's go back into Unity and see what our player looks like and if we can jump now. Any second now, we should be able to select the player. We can expand out our player script here, and you can see that we have a jump velocity that has a 0 and a 0 in it. Let's hit play real quick and see what happens if we just go in and start clicking. So I'm falling. Look, if I click, I fall slower, but I never actually jump up. Let's change this jump velocity by going into the Y section here and just putting in a value of 1. I'm still playing, by the way. And now let's hit jump. Look at that. I can kind of bounce up and down a little bit. Let's try turning this up to maybe like a 5. There we go. Now I can actually jump at a reasonable rate, and things are, I think, kind of gamish. Let's stop playing and see what happens. Look at that. That Y value went right back to 0. The reason for this is that when we change things while we're in play mode, those changes don't save. Let's try it again. Let's change this to maybe a 3. Hit play. We'll jump around a little bit. So I jump. It looks pretty good. And if I change this to maybe like a 10, so I can do a big jump, you can see I do giant jumps, but I stop playing and it goes right back to 3, saving off my value so I can kind of experiment at runtime when I'm playing my game without losing all of my saved data or my saved settings. So far, things are looking good. I've got a jumping player and I'm ready to start giving him some threats. But before we get started, I have a big announcement I want to make. I'm very excited to let you know that my good friend Thomas Brush and I are launching the Ultimate GameDev course. It's a huge online course with over 120 hours of content where Thomas and I have bundled our courses and knowledge together at a crazy low price. The course includes all of my courses that'll take you all the way from having never looked at code before to using Unity on a professional level, and Thomas's course. You'll learn all of his secrets on how to secure 6-figure funding from publishers, crowdfunding, how to get your game onto the Steam front page, and hopefully how to go full-time and make a living solely creating games. With my courses, I'll teach you everything about C# coding in Unity, good workflows, tips and tricks on how to get your games done faster, and ultimately how to successfully scale your games. You'll learn topics such as multiplayer, AI, animation, quest systems, and a ton more, all while building a variety of game types like 2D platformers, RPGs, top-down hack and slashes, first and third-person shooters. Once you've mastered all the skills to create your own games, you can polish them up with the amazing art skills you've learned from Thomas's course. The Ultimate Game Dev course will only be available from July 1st to August 1st, and to ensure everyone gets the best experience, we've had to limit this offer to only 300 students. And as a special early bird offer, everybody that signs up within the first 24 hours of launch will receive a free and unique Ultimate Game Dev hoodie. So definitely go check it out by clicking the link in the description to get more information. And sign up for the email list to get notified when it goes live so you can get your Ultimate Game Dev hoodie included free and ensure you get a spot before they run out. The threat to our player is going to be those pink moving blocks that push it back into the red zone that kills the player eventually. Let's create our first moving block by going to Game Object, 2D Object, Sprites, and choosing Square one more time. We'll name this moving block by going to the inspector, clicking there, and typing in moving block, and I'll put a space in the name. I'm going to set the X position to 0, and for the Y position, I'm going to put in a value of -3. So just hit the minus key right next to 0, and then a 3, and click right out of it. I'm going to change the scale of it, the Y scale, to make it twice as tall by putting in a 2 instead of a 1. Now you see that I've got this nice little block that's about the right size and in the right position, just the wrong color. Let's expand out the sprite renderer. Choose a color, and I'm going to go with that pink that you saw earlier. There we go, a kind of light or bright pink. Looking good so far. The next thing I need to do is add in my collider, so I'll go to Add Component. We'll clear out the search that I have there, go to Physics 2D, and then let's find the Box Collider 2D component. That'll allow our player to bump into it. Now, if I hit play, I should be able to jump around and see my block there and have my block just kind of sitting still, but I can't interact with it yet. I need to make some code now that's going to move our block over to the left constantly to push our player out of the way. To do that, we'll create a new script. So I'll right click in my project view, choose create, choose C# script, and here I'll give it a name without hitting anything else. I'll call this moving block with a capital M and a capital B. Again, following that Pascal case where we capitalize the first letter of every word. I'll hit enter. That'll give it the name and create the file. And notice that it opened up Unity's code editor or Visual Studio without going into the file. That's not a problem. I can minimize this and just go double click on it again and have it open up my moving block file. Now in my moving block file, I don't need my start method, just like I didn't in the player. So I'm going to select everything from line 12 to the beginning of 7 and delete it out to just clear that out. I can also hit shift and delete to delete out line 7 as well, because I just didn't need it. It's an extra bit of space there. To move our block, we need to access the transform component and tell it to move its position over to the left. We'll do that by adding in a line here on 10 saying transform, which will directly access the transform component. We don't need to use get component with transforms. They're automatically cached and every game object has one. We'll set the position by doing position. Well, we're not really going to set it. If we were going to set it, we'd do equals. Instead, we'll do plus equals to modify or add to the position. And we're going to add in vector 3, not vector 2. And the reason for that is because we're using the transform component, which uses the 3D vector. You saw that we had an X, Y, and a Z. We're ignoring the Z, but it's still there. So we're going to use vector 3 dot left. That'll move us left along the screen. Now, if we just do it like this and we add in a semicolon, it's going to move extremely fast. What would happen is every single frame, our position is going to move over by 1 unit to the left. Let's go into Unity and see what that looks like. In fact, let's save, hit play, see what it looks like, and then I'll show you the quick fix for it. So if we go into here and we select our player, I'm going to first hit pause. Watch this. Oh, I want to select the moving block, not the player. I want to add in, oh, I see where I've missed to. I also need to add my moving block to it. Now let's hit play. And let's watch the position. Watch this X position. It's at -1. If I step forward 1 frame, it's at -2. Another frame, -3. Another frame, it's at -4. And so on. You see that, look how fast that's moving compared to how fast my player is falling. Look what happens if I stop the pause. If I unpause, look at that position. It's flying far, far away. If I zoom out, it's way past. It's off the screen. So I need to change this and make it adjust to only move 1 unit per second instead of 1 unit, well, 1 meter or 1 unit per frame. To do that, we'll go into our moving block and we'll just multiply this vector 3.left times with the star, which is shift and 8, time.delta time. That's a uppercase T and then a lowercase d and an uppercase T again. That will give us the amount of time that's passed since the frame. Now, if you're into frames per second calculations, you'll know that 1 divided by 60 would give us the value of this for a 60 frames per second game. And then we'd multiply that value times the point with the 1 on the left vector. That's how much we're moving. Let's go see what that actually looks like, though, because just saying it out loud is just a little confusing. Might not make a lot of sense. Let's see how it moves, though, when we use this. We hit play. Well, let's hit play again. There we go. And watch our cube. There we go. It's pushing over to the left, and our player is getting pushed to the edge. If I jump, I can get up a little bit. I could probably get over it. But eventually you'll see that now my player has fallen, and you probably saw him falling way down there off the edge of the screen. So it's working. Our player is now able to be pushed off the edge. But we don't have any way to control how fast it's going. It seems a little bit slow, and I want to make a couple more changes. So let's go back to our moving block, and let's modify how fast this thing is moving. Instead of just moving at 1 unit per second, let's move at maybe 5 units per second. To do that, we can add in a speed multiplier. So I'll just go right to the end of the time.delta time before the semicolon there. The semicolon is ending the statement. I want to go before the end of it and multiply by move speed. Again, I'll use Pascal case, and it won't automatically create it. It's not going to exist on its own. I need to hit Alt-Enter and generate a field for it. It's going to create it right up here, or we could go up here and type it. Now, this is an interesting thing because when we create a field with this automatic creation, it's going to use a vector3 as the type, and that's not really what we want. We want to use a different type, one that we haven't used yet, and that's a float, which is really just a number with decimal points. When you see floats in game development, just think of it as a number that can have a decimal point that's used for fast calculations. Floats are one of the most common things that we'll use. The other one that you'll see a lot of is int. Int is an integer, which is just a number without decimal points. We need to change this to a float, though, so I'm going to select the part that says vector3 right here, only this one. Don't select the one down below, and type in the word float. We're going to give it a default value, so I'll go to the end of it, type equals, and I'll give it a value of maybe 3, and then I need to add in the F as well because it's a float. I want to change this private keyword. I don't need it. It's somewhat redundant. It works the same without it. I could just delete it. It would be exactly the same. It's just kind of extra knowledge and something that used to be required and is no longer. But I want to replace it with the serialized field attribute, just like we did in the player. If I click on the player, remember this field right here, the serialized field attribute, made it so the jump velocity showed up in the inspector. I want to do the same thing here by adding a square brace next to the P, serialized field, and closing out the square brace. I can save my file with Control S, do a build with Control Shift B. Just make sure that everything's good. It says my build has succeeded. Let's go into Unity and see if my block now moves faster. And there we go. You can see the block is going quite a bit faster. Watch this. If I select the block and I change the speed, drag it maybe over to a negative value, look what happens. There we go. Now it's going back the other way. Let's drag it to a positive value. Hey, it's going to the left. Negative, it's going to the right. Pretty cool, right? Now we can modify it and play with it in the inspector. Now let's add some more obstacles. Only having one is way too easy, and you saw in the demo that we have quite a few. I want 3 in a row, and I want stacks and stacks of them. Now, I don't want to go through the process of manually creating them over and over and over, so there are 2 options that I have to speed things up and save myself a whole bunch of headache. One option is that I can go to my moving block and I can just right click on it and choose the duplicate option. That's going to give me a second block, and if I go over here and just drag around, I can actually move this block. Now, if your movement area or your UI doesn't look just like this, go over to the Rect Transform tool right here and select it. You might be on this tool, the Move tool, or the little hand tool where you don't see anything and you can't select anything. You go to the Move tool and move it around, or you can go to the Rect Transform tool and move it around. Just don't grab the corners here because then you'll end up resizing it. If you do make a mistake, you can always hit Control Z and undo. But what we're going to do now is just delete the second moving block instead of having that duplicate. Instead, what we're going to use is called a prefab. It's a prefabricated object or game object that we're going to reuse in our game. We're going to make this moving block into a prefab, and that's done by just taking the block from this hierarchy and dragging it down into anywhere in this empty area of our project view. You'll see that now we have a version of our block down here, and this thing has turned blue. If your view looks a little bit different, you might have this slider over here to the left so that you just see it as a list, or you might have it all the way over here to the right and see it slightly bigger. That's why it's different. Just drag this around until it matches and you can see what I see. So now we've got this moving block prefab. It's got a couple of different things on it. First, I can click the little arrow. If I click the arrow, it's going to go into this prefab edit mode where I can make changes to the prefab and it'll apply to all instances of it. I'll talk about that in a moment. Let's go back though by hitting the back button. Now that our moving block is a prefab, I want to do that duplication again, and I'll explain why we wanted it to be a prefab in just a moment. First, let's duplicate it with Control D or Command D, or you can again right click and get the pop-up menu. I like the shortcuts though. With it duplicated, I want to be in move mode. So if you're in rect transform mode, just hit the W key on your keyboard or switch over to move mode. Hold down the control hotkey and drag up the yellow arrow here until you get to the value of 0.75 or just enough space. And I said yellow, it's actually green until you start dragging it. So I want just enough space that my cube can fit through with a little bit more room. So 0.75 looks like the perfect value. And in fact, you could just type that in if you prefer. Now I'm going to take this moving block here, go select it one more time, duplicate again, hold down control and drag up again until I get to about, I think I want 4.25. That's about a perfect amount so I can get through both of those. Now let's hit play and see if I can get past this little mini super simple puzzle. Yeah, pretty easy, right? There's only one set of blocks. Let's change this and make it more difficult. To make it more difficult, we're just going to add in more blocks. So we'll select all of these blocks. I'm going to select number 1 here, hold down shift, and then select the last one. So I've got all 3 of these selected. Now I'm going to hold down control and hit D, or again command and D, to duplicate them. Now I've got 6 blocks. I'll hold down control, hold this right arrow and drag it over here until they all get to a position of, I think, 5. 5 meters out is a good spacing. So now they're 5 over and I've got 6 blocks. Let's make some more blocks. I'll hold down control, hit D again, still holding control, drag over another 5 until we get to that 10 mark. You know what I'm going to do next? Yep, I'm going to repeat the process. Hold down control, hit D, drag them over until we're at 15. Now I'm going to zoom out because I can't quite see. So I use the mouse wheel and then I'll hold down the right mouse button. I haven't left clicked at all. Notice I still have my selection. And I'll just drag over here and now I've got them kind of recentered. I'll do this one more time. Control D, drag them over here until I get to 20. And then I'll do it one more time. Control D and we'll go all the, oops, I missed it. See, that time I accidentally messed up. So I'm still holding control. I'll hit Control Z, get them back in position. Hit Control D one more time, and again, it's Command on a Mac, and still holding Control with the snapping on, just drag them over. Now, if any of your positions get messed up or anything, feel free to just type them in, delete them, or whatever you want to do to recreate them. Just get them kind of into position. Let's hit play now and see what this is like. All right, look at that. I've got these little blocks. Uh-oh, I almost missed my jump there. I've got the blocks pushing me to the edge. They're almost pushing me off the screen, but I made it through. And now let's pause. I hit the little pause button here. Notice the game execution will pause and it'll go right to the scene view. I'm going to hold the right mouse button and drag over here and look at all of our blocks. If I unpause and go back to that scene view, I see that they just keep going and moving to the left forever. So our next step is going to be to make these reusable. We have a couple options. We could theoretically just drag them out and make infinite copies, hundreds and hundreds of copies all the way along and position them exactly where we want. Definitely not what we want to do and not what a normal game would do. Instead, we're going to reuse these and reset them, and we'll do that with code. To make our moving blocks reusable and resettable, we're going to make a change to our moving block code. So we'll open up the moving block script, and right below line 12, we're going to add another if statement. An if statement kind of like we did in our player script here. Instead of reading the input though, we're going to look at the position of our object. We'll say if transform.position.x. Now this is going to read the x value of our transform's position, the object or the moving block's position. This is that value that's at 0 by default on the first one, goes negative when we go to the left, positive to the right, and we place them at 0, 5, 10, and so on. So if this value is less than or equal to, so a less than followed by an equal sign means less than or equal to. I could also do less than, but I'm going to do less than or equal to. This is just the proper way to do it. If it's less than or equal to, and then I'm going to put in a value of negative 15 or negative 15, then I want to reset the position. So to reset the position, I'm going to go down and create a new line here. And notice that the statement that we're evaluating is inside of these parentheses. This is very important. The if statement requires something inside of parentheses for it to evaluate. If this is true, then the code after it will be run. If this is false, the code after it will not be run. So if the position is less than negative 15, meaning it's moved far enough to the left that the value got below negative 15. We'll go take a look at that in a moment. Then we want to reset it and move it over to the right. To move it to the right, we'll just say transform.position plus equals vector3.right. We're going to move it to the right, and we want to move it to the right 30 meters. So if we go to the left 15, we'll pop it back to the right another 30 meters. So we'll do right times 30f. F again is just a value or a key that we need to put on floating point values when we're multiplying them. So if it's a float, we put an F there. It's a little bit weird for game development, something that you might not have seen if you've done other programming. Just get used to it. All right, so this will reset it back 30 meters to the right. Let's go take a look at that, see it in action, and see how it works. So we'll minimize Visual Studio, jump back in here to Unity, and now because we have these prefabs that all have the same script, they're all going to get the same behavior update. Let's watch as they move to the left and then move to the right. Now I'm going to go right over to the scene view instead of looking in the game view. I'm going to select one of these and let's watch the position. Oh, did you see that? It just snapped over. Look at the X position of this moving block. It's this one that's selected right here. When it gets to negative 15, it's going to reappear right over here to the right, just along with the other three. So now I've got these sets of rows of moving blocks moving back and forth. Let's go try it out real quick and actually play it. So here we are, we go in and I can jump through, and I could probably do this forever because they're just going to keep resetting to the exact same position. So far, this game is working, but it's got a couple little issues. We need to add some difficulty by, I guess, modifying or randomizing the positions. Oh, look at that, I actually hit something. All right, let's stop playing and let's make a change to our moving block script again. We're going to go back in here, and when we do this resetting of the position, let's randomize our height as well. So instead of being at the same position that we were at on our Y value, let's modify it by a little bit of a random amount. To do that, we first need to keep track of what our initial Y position is. We need to save that off somewhere so that we have something to use as a point of reference. The reason for this is that, well, if we keep changing it every frame or every time we reset and we move it up or down some random amount from wherever it is, eventually it could just move all the way up off the screen. Imagine if we moved it up or down by 1 meter randomly, and we go up 1 meter, and then next time we go up another meter, the next time we go up another meter. Eventually it gets all the way off the screen, could totally disappear. So that's not what we want. We want to go up or down some amount from our starting point. We're going to need to cache that starting point or save that starting point. To do that, we can re-add our start method. That method that we deleted earlier, let's go re-add it now. Before we do that though, I'm going to delete line 9 here. Line 9 is in green, and it's got these 2 forward slashes. That actually means that it's a comment. It's not code that actually executes or does anything. It's a note there for programmers to read to understand more about what's going on in the code. Since we now know that update's called once per frame and every script we create is going to tell us that, we can just delete that line out. I'm going to now add in one more line. Go right here on 9 so that I've got a little bit of spacing. Now technically the spacing doesn't matter, but if you want your code to be readable and make you happy, add a little bit of spacing, keep things nice and clean. So what we're going to add here is the start method. I can start typing the word start and just have it autocomplete by hitting enter, or I'm going to hit Control Z. I can type in void start open close parentheses. There we go, and it's still auto completed for me. Now again, I mentioned that this private keyword isn't necessarily needed, so I'm just going to delete it to shorten up our code. And then let's go add in the piece that we need, saving off our starting Y position. To do that, we're just going to say starting Y position equals transform.position.y. I messed that up a little bit, just fixed it. All right, so we're going to save the Y position into this variable named starting Y position. This doesn't exist yet, so we're going to hit Alt Enter and generate a field for it. Again, if that doesn't work for you, you can just go up here and type this in. And also, we don't need that private keyword, so I'll delete it, add a little bit of space, and make it look nice and pretty. So now we're saving off our Y position when the game starts. So each block will know what position it was when it started at, because they all start at different positions, and if I move them around, I don't want to have to change code to modify that. With our starting position saved off, now we can randomize the height or the Y position of our blocks when they reset. We'll do that down in our resetting code right here on line 22. We'll add in a new line, and first let's calculate out a new Y position. We'll say float new Y equals, and we want to use our starting Y position, so starting Y position right there, plus Unity engine.random.range, and we want to give it a value of -1 f to +1 f. So we're going to give it plus or minus 1 meter from our starting position. Now here it says that this name can be simplified and we can remove that using statement. The reason that I leave it in there is because if you have a using system statement up above, you're going to run into some conflicts and errors. So I recommend just leaving it for now. Now that we have our new Y position in a float, let's reset our transform position one more time. We'll say transform.position equals, and here we'll create a new vector 3, which is going to be a new position that we can set, and we have to give it our existing X position. To do that, we'll go transform.position.x, reading our current X, and then our new Y position, and then our Z position. Here we can either read transform.position.z, or because we know we're working in 2D, we can just hard code that to a 0 and keep everything right there at 0, 0. If these values are not lined up, we'd end up with some weird problems and not have collisions. So we want to make sure that that's at 0 and just set it there like that. I'll save that off with Control S. We'll go back into Unity. Let's hit play and see how well our game works now. All right, we're jumping. You should be able to jump around, and then when you get to the end, look at that. The block's position is starting to get randomized, and things are getting more and more difficult. And I might be able to squeeze, yep, just through that hole. Now, if you're having a hard time squeezing through the holes or fitting through things, just make sure that you've set your sizes and everything to kind of match. Also, if you're seeing the corners reappear, the edges there, remember that this free aspect drop down just needs to be changed to full HD to get rid of those extra edges. Now, you saw my player fall off the edge, so I think it's time to stop playing and give ourselves a way to end the game or kill the player before we start adding up points. First, though, let's save. To kill our player, we're going to add in another big red block. Let's go create a new game object now. Game object, 2D object, another sprite, and another square. This time I'm going to zoom in a little bit, and I'm just going to move it over to the left. Remember, W will put you into, oops, I'm in rename mode. Let's hit escape there. W will put you into move mode. T will put you in direct transform mode. I'm going to go to W and just move this over here to the left somewhere so that it's just off the screen. Now with my mouse over this part of the screen, I'm going to zoom in with the mouse wheel and get it so that just this edge, or maybe this whole block right here, is on my screen or inside this white area. I can go to the game view to see that and just double check that I'm seeing it right, or I could even drag these side by side if I wanted. Remember again, if your layout gets messed up, you can go to Window, Layouts, and then choose Default to reset it. I'm going to now move this block around and resize it so that it fits exactly where I want. So I'm going to zoom out, use the right mouse button. I'm going to move this over here just a bit. I'm going to take the top of it here. This is in direct transform mode, or T here, this button right here. Drag it right up to the top and then down to the bottom. And then I'm going to make this thing red. I'm going to add a box collider to it. So we'll go to the Physics 2D section and choose Box Collider 2D. Expand that out. You can see that I've got this green area around it. And now I want to make this box kill our player or restart the game when the player touches it. So first thing I'm going to do is rename this from square to kill area to make it seem menacing. Then I'll expand out my scene because I couldn't see it here and save just to make sure that everything looks good. And we'll create a new script to kill the player. We're going to right click in our project view, hit create, choose C# script. And I'm going to call this kill on touch. Capital K, capital O, and a capital T following that Pascal case again. I'll hit enter and hit enter one more time to open up the script. And again, if it doesn't open automatically, just go back into Unity, double click it again. It should enter. This time I don't want start or update. So I'm going to actually select everything from line 7 to 17 and delete it all. Now I just have an empty class named KillOnTouch. Inside of this class, we're going to deal with a collision, a 2D collision to be specific. And we're going to do that by typing on collision enter 2D. I'm going to go find the automatic auto-completed version of it and hit enter and let that fill in. Now, if this doesn't auto-complete for you, just type out what you see there. Void on collision enter 2D, matching the case, collision 2D, collision. Match that out. You don't need the private keyword. In fact, I'll delete that myself. So if we touch something, if we get a collision, what's going to happen is this method is going to be called automatically by Unity. As soon as anything touches this, this method will get called by Unity. What we want to do in this method is check to see if the thing that collided with us was the player. To do that, we'll say if collision.collider.compareTag, and then open parentheses and then open quotes, and then we'll put in the word player. So if the thing that collided with us has the player tag on it, then we want to run some code. And that code is going to be to reload our game. I'll add in some braces here. And to reload our game, we need to use the scene manager. We'll type in scene, S-C-E-N-E, manager, get the capital M. And I'm going to hit escape and notice that there's no autocomplete there. It's not blue and it's not correct. What I want to do now is hit Alt-Enter and add this using UnityEngine.scene management. If you don't see that, it's okay. You can type this in manually. You may have just typoed something or there may be a problem with your autocomplete. But I'm going to hit Enter and just allow that to automatically add. Again, if you don't get that option, you can just type in using UnityEngine.scene management. This is pulling in those namespaces or the external libraries that I had kind of mentioned earlier. Unity's scene management system is one of those that you need to pull in if you want to reference it inside of your scripts. So when we get touched by a player, we want to tell our scene manager to load a scene. We're going to call load scene with open parentheses, and the scene we want to load is the currently active scene. To get the currently active scene, we can call scene manager dot get active scene and open close parentheses, and then use a dot to access the name of it. So I'll go to the end, add my semicolon to wrap up the statement, and allow you to just take another peek at this full statement. Scene manager.load scene, scene manager.getActive scene name. So we're getting that name of the scene and then reloading it. Let's save, and then we'll go back into Unity, add this script to our object, and assign the player tag to our player. Now that our script is ready, let's add it to our kill area. So I've got my kill area here. I'll drag the kill on touch script over to it. And then let's go to the player and choose the player tag. Up here I can select a tag, and player is one of the default tag names. So I'm just going to use that. Again, you need to make sure that the casing matches capital P, L-A-Y-E-R, all lowercase. Let's save our scene one more time with Control S, hit play, and let's see now if my kill area will kill the player. I expect that it will though. There we go, he slides back, and bam, the game restarts. Now I can jump and jump and jump, try to stay alive as long as possible and not die, and you can see that I can get pretty far. There's still a little bit of an easy way to cheat though. I can go all the way up to the top and just kind of fly above these blocks and never die. If I keep clicking and pause, eventually I could go over to my scene view and you'll see that I'm way up here. So let's stop that by adding a ceiling. To do that, I'll go to my ground. We'll hit Control D to duplicate it. I'll rename this to ceiling. And then I'm going to hit the W key to go to move mode, hold control so I get my interesting snapping, and then just drag it up here to the top. I want to drag it up so that it's just below this little line here so that I have a little bit of a hint of it on the screen, and then give it maybe a bluish tint to indicate that it's a sky. So go to the color and select maybe a blue or a bluish purple. I don't know. I'm thinking just a light blue seems good. Something kind of like that. All right, go back into my 1920 by 1080 aspect ratio. Oh, I need to go back to my scene view now with that aspect ratio fixed and just drag my kill area over a tiny bit. And now things I think are just about there. We've got a game now that's playable and everything is working except for the score. Now we're going to add scoring to the game. Scoring will make it a lot more interesting. We'll keep track of the current score and the high score. We'll learn how to set up text elements on the screen so that we can see both of those scores. And you'll learn how to reference objects across other objects or reference one game object from another. Before we get started with that though, I did want to ask if you're still along with me here, please hit the thumbs up button. It really does help. It helps with YouTube. It just helps make me happy as well. Also, leave a comment and say hello or anything else. Or check out the free course on game development that I've got linked down below where you can go quite a bit deeper and build out some Angry Birds. All right, let's go through this process now of adding score. The first thing that we want to do is add some text. And to do that, we're going to go to Game Object, UI, and then we're not going to choose text. We're going to choose this second option, Text Mesh Pro. This is just text that looks quite a bit better. If you want to have really ugly text, choose that one. If you want to have pretty text, choose the Text Mesh Pro option instead. And that's what we're going to do. It's going to give us this little menu to pop up, or this little pop-up that gives us an option to import the essentials, the TMP essentials, which is short for Text Mesh Pro. I'm going to hit that button, allow it to import, which will give me another little pop-up in a moment. There we go. Oh, it actually popped over to Visual Studio, which was a little bit strange, but not a big deal. I jumped back over to Unity, and I also want to import in the examples and extras. This is just going to give me some extra fonts and a little bit of cool functionality that you can go play with later in the example scenes. I recommend pulling it in, though, if you've never used Text Mesh Pro, or if you want to use the fonts that I'm going to use. Once this is done, we're going to modify our text element that you can kind of see down here in the bottom left corner. You can see it says W text. It's actually saying new text. I don't know why it keeps popping into Visual Studio, but we'll just minimize that again and go right back in. All right, let's go modify our text element now. So now that it's done, I'm going to close this window and I'm going to go to the scene view here. We're going to double click on this text and look at that. It's giant. It's way bigger than our actual game. Let's zoom out with the mouse view. Or the mouse wheel, not mouse view, and use the right mouse button here to drag around. Here you'll see that we have another big white area that doesn't match with our game's white area. The UI elements are actually drawn very separately. So our UI elements are not drawn the same as our game elements. Notice that our text isn't giant and way off the screen when we go to the game view. It's actually down here in the bottom left corner. It's using this view. So what do I want to do with this text element? The first thing I want to do is move it right up to the top. I want to get it right up here so that my score is kind of showing, I think, right around in this top right corner. To do that, I've got my text selected. I'm going to go select my Rect Transform tool, this one right here, by left clicking on it. I'm going to hold down Alt and Shift. If you look here, you'll see that Shift sets pivot, Alt sets position. I'm holding both of those down, and I'm going to click on this little box right here to anchor it to the top right corner. That moved my text up here, and if I go to the game view, you see that my text is now in the top right corner. I'm going to change the text. Instead of saying new text, I'm going to put the value 100. Just say, hey, I got a score of 100. Not my real score, but let's just say that that was it. And then I'm going to change the font size here from 36 to maybe 200. I want to adjust this a little bit in the scene view, so I'll go to the scene view here, and then I'm going to go to the Rect Transform tool and make this quite a bit bigger. Right now, the 100 is scrolling way down here because my font size is bigger than my height of my text. If I zoom in here with the mouse wheel and drag this down, and then drag it over here, you'll see that the text now fills into the box and it fits quite a bit better. I do want to change the font though. I want to make it match what you saw in the demo, and to do that, I'm going to select a new font asset on this Text Mesh Pro asset. And by the way, if you're not seeing this, make sure that you expand it out. If on this Text Mesh Pro asset though, you should see a font asset option, or this Text Mesh Pro component. You'll see the font asset option. I'm going to hit the little search box here, this little dot, and it's going to show me all of the fonts in my project. Because I pulled in the extras package, I have this electronic highway sign, and I'm going to use that. I'm going to just double click it to select it, and that will be my new text for my score, or my new high score text. The next thing I need to do is create some code to keep track of my high score and set this text to update to my high score. To do that, we're going to create a high score text script. We'll right click in our project view, choose create, choose C# script, and we'll call this high score, no, not high score text, score text. This isn't our high score yet, we're on the score. So this did not open up my score text, it opened up my previous file, so I'm just going to go back in, minimize that, double click on the score text, and open it up. Inside of my score text, I want to do one thing. I want to update my text to have whatever my current score is. Now, I don't have a current score, so I'm going to need to figure out a place to get a score first before I can have something to show. But where could we get a score? Let's go back to our game and take another look. In our game, let's just double click on a moving block to zoom in and then zoom out with the mouse wheel. It's a little bit hard getting back and forth between those two. I just recommend double clicking on an object and use the mouse wheel. So in our game, we move blocks to the left. When a block gets all the way to the left, it resets, and that seems like a good time to add points. In fact, that's when I was adding points because it's the easiest thing to do. We'll open up our moving block script, and what we can do is when we reset our object, or when we reset our moving block, we can just increment a score variable. Now, I had mentioned before that floats were one type of number that we store that has a decimal point, and ints are another type that we store that don't have a decimal point. So what we're going to do is create an int. We'll say int score. This will be an integer that keeps track of the score. Now down below in our update method, right below line 24, we'll say score plus plus. Score plus plus actually just means add 1 to score. Plus plus after any integer just means increment it by 1 or add 1 to it. Now if I do this, it's not actually the correct behavior. What we'll get here is at every time a block moves all the way to the left, it will increment its score value by 1. Let me show you what I mean, and I'm going to show you a neat little trick here as well. If I add the public keyword here in front of my score, it's going to show up in the inspector. Let's go to Unity and see it. So if I go select one of my moving blocks, I'll just go select this first block. You'll see that it's got a score of 0. And if I hit play, watch what happens as it goes past. So it's got a score of 0. Oh, I'm dying. Let's stop myself from playing. To stop myself from playing, I'll go over to the game object for my player, and I'm going to uncheck it to disable it. Notice he'll disappear from there. He'll turn gray in here, and he is no longer active. I no longer have a player in there, so I can't die and my game can't reset. Let's hit play now and watch our moving block go by. So you see that my value is not at -15, but once it hits -15, it gets a score of 1, it resets, and then eventually it's going to move by again. When it gets all the way over to the end and resets, it'll get to a score of 2, and so on. But each of these blocks has their own score. This one's got a score of 1 right now. It's about to get to 2. And this block's probably about to hit 3. So that's not what I want at all. I want the score to be a shared value across all of my moving blocks. Luckily, there's a very easy way to do that. A nice, simple, cheap, simple way. And that's to just add the static keyword right here in between public and int. If we make this a static integer and save, it's no longer going to show up in the inspector because it's not a per instance or a per game object variable, but it will be unique or persistent for all of them. It will be shared for all of them, I guess is the correct way to say it. A static variable, there's only one of for all of the instances of this class, and they're all going to reference it. Without the static keyword, they would each have their own score. Now that I have this score variable available and it's public, we're going to go back into our score text. And in our update method, we're going to get our text mesh pro text object, and we're going to set the text of it to be whatever our score is. To do that, we'll say get component, and we need to give it the type with the less than symbol, the shift and the key next to M, and give it tmp underscore text with get the casing exactly right, hit escape, alt enter, and add the using tm pro statement to the top. You'll see that that has appeared here. I hit alt enter and just added it automatically. Now I'm going to add my open close parentheses here after the closing less or greater than symbol. We'll do a dot, and we want to set the text with set text, open parentheses, and then we need to give it the text that we want to set. So what this is going to do is just change the text of that to whatever we put. If I put in the word Jason here, add in a semicolon and close that off with my quotes and my parentheses, save and go into Unity. Let's see what that does. Okay, we've got our text selected. I need to go add my score text script to it. Dragged on. I've got the score text here. I've got it set to set the text to my name. Let's see if that works. There we go. It says, hey, there's Jason. Looking good, but not what we wanted. We wanted the score. So let's go figure out how to do the score instead. Instead of using Jason here, I'll delete that, and we'll use moving block dot score dot to string. Now this is an important thing. If you're used to programming, you might think like, hey, why can't I pass in something that's not a string and have it automatically work? That works for most things in C# and most things in Unity, but set text requires a string. Because score is a type int or a number, it needs to be converted into a string or letters, which is like the 100 or whatever the value is, before it can be passed into set text. Let's save this off, go back into Unity, and see now if we have a beautifully working, amazing scoring system. Let's try it out. Now, again, my player's still not active, so I can't die, and it's a nice way to just watch as my score goes up without me having to sit here and jump. Let's try it out and see if it works, though. There we go. Score went up by 3 and by 3 and by 3. And you'll see that it goes up by 3 every time we pass through there. And if I turn on my player, go to my player, I can just check, turn it on, and get in here and start playing and see how high my score can go before I mess up, make a mistake, and fall back into the wall there. Let's see what I get to. Look at that. Made it to whatever that was, 39. But if I let it keep going, notice that my score didn't reset. So I need to restart my score. Let's stop playing, go back into our moving block, and make our score reset. To reset our score, we could just set our score to 0 in the start method of our moving block. So right down here on line 14, we'll add a new one for 15, and we'll say score equals 0, and we're done. That'll reset our score now every time we load our level. And remember, we load our level when we die and we restart, so our score is just going to get set to 0. Now let's add a high score text, and our high score text is just going to be a quick copy of our score text. We'll go into our score text file, and I'm actually going to delete out our start method here completely, clear that all out, and make ourselves a nice short class. Now I'm going to show you another way to create classes, a way that I normally do it when I want to create new C# code. I'm going to copy this class completely, everything from line 6 to 12. Hold down Control and hit C to put it onto my clipboard, or you can always right click and choose the copy option if you prefer it that way. Go down below and hit Control V to paste it. And then I'm going to change the name of this one on line 14 so that it's not an exact copy. Instead of being score text, I'm going to name it high score text. I'm going to hit Alt Enter and hit move type to high score text.cs. This will actually move the file or the class into its own file named high score text.cs. Let's minimize Visual Studio, go into Unity, and you should see as it recompiles, the new file will appear here. I've got a high score text. Again, remember there's a little slider here, so you can go to list view and big view or big icon view so you can see models and images and icons, or if you can want to see file names and long lists, you can switch back and forth. Here I can see I've got my high score text though. I'm going to open it up and I'm going to make one change to it. Instead of reading the moving blocks score, I'm going to read the moving blocks high score. Now, that doesn't exist, so I expect to see a red underline. There it is. I've got my error, and I just need to go fix it. I'm going to save this file though, and then I'm going to go into my moving block. Right here I've got a score. I'm going to select the entire line, copy it. I'm going to go down to the next line, paste with Control V, and then hit enter. Add in the word high here. So now I have a high score and everything is almost done. The last thing I need to do is modify my high score. If I save this and I go back over to that high score text, you'll see that the error is gone. Everything would kind of work here if I started to use this, except high score is always 0. In fact, let's go set that up. Let's make high score show up as 0, and then let's figure out the simple logic to make high scores work. We'll go back into Unity, and we're going to create a high score text object. First, I'll let it recompile. We'll go to our score text here, this text object. I'm going to zoom out, right mouse button to drag around, and I'm going to name this score text. So I'm going to click in here, go over to the left, name this score text, and I'll leave the TMP. And then I'm going to duplicate it. So I select it over here, Control D or Command D, and then I want to realign this so that it's centered here. This is going to be my high score. So I'll select my Rect Transform tool, hold down Alt and Shift, and hit this center alignment. I'm going to name this high score text. So I'll go to the beginning, high score text. I'll get rid of that extra 1 there. And then I'm going to shrink this down a little bit. I want my high score to be a little bit smaller. Maybe I'll make this a font size of like 100 or something. And then I'll center align it right there. And I think I even want to add in a little bit of an outline. And I'm going to vertically center it there too. Drag this up just a little bit to shrink it. I think that looks good. Now let's add a little bit of an outline while we're at it too. Pretty things up. To add an outline, I can scroll down here. Below my score text here that I've got, which I need to remove in a moment, I have some options for my text. I've got an outline, an underlay, and some other options here. If I switch this off of mobile from Text Mesh Pro mobile distance field to Text Mesh Pro distance field, I can even get more options. But for now, I just want to check the outline box and drag up a border to get myself a nice little outline. I don't want to modify it too much. Next thing I want to do is remove this score text component because I duplicated my score. I have that on there. I want to remove it and then add in the high score text. We'll hit play and watch what happens with our scores. The high score should stay at 0 and the score should go up as the blocks go past. Let's watch and see. There we go. Looks good. Let's stop playing now and finish it up. The last thing we need to do is make our high score go up whenever we beat our current score, or whenever our current score beats our high score. To do that, we'll go into the moving block, find the code where we're incrementing our score right here on line 27, and right after it, we'll say if score is greater than, so not greater than or equal to, but greater than high score, then on the new line, we'll add in our braces and say high score equals score. Add in a semicolon, save that off, minimize, go back into Unity, and you'll be amazed to see that we are done and we now have a working game with high scores, jumping, and almost everything except for a player because we've disabled it. First, let's test though. Let's make sure that it works. So here we go through. My score goes up with both, looking good. All right, I'll stop playing. Let's hit player, turn them on. So I select the player over here and I need to check this box right here. Check it to enable the player. He should no longer be grayed out. It should look that nice lighter gray, I guess, less grayed out. And then we'll hit play. And now I should be able to see my score go up and then see if I can beat my score the next time around. All right, so there we go. I've got a high score of 6, of 9, and so on. And let's watch. So my high score shouldn't change as I get to 3. Shouldn't change when I hit 6. Shouldn't change when I hit 9. But as I get to 12, there we go. The high score is keeping up. And now, I guess we just see how long I can go and how high of a score I can get while I try to convince you that you should hit the thumbs up button, subscribe to the channel, and just get more into game development. And if you're really enjoying this stuff, also consider just taking my free course on how to make a game where we go through Angry Birds and build out the almost entire game with a couple different birds, a couple different obstacles, and give you the ability to build out your own levels and have some fun with it. There's a bunch of different art available, a bunch of birds, backgrounds, and other things, and just a lot more learning that you can get into. Or of course you can check out my other courses that are available as well. Also, don't forget to check out the Ultimate Game Dev course. You can do so by simply clicking the link in the description. I also highly recommend you sign up for the email list so you get notified when the course goes live, and you can grab the early bird offer, get yourself a Game Dev hoodie, and get in before spots run out.